Hello and welcome back to another tutorial on composing with OpenMusic. In this video we're going to be looking at constructing a pitch circulation counter, and while we're doing that, looking at some ways of working with lists to organize data as we go. So we'll go ahead and get started here, and I'm going to pull up actually the template that I used when I made this, and we'll kind of work through this together. So let's see. Okay, here we go. Awesome. So I'm going to go ahead and make a new patch over here. And there we go, yeah. We'll call this pitch circulation counter. Great, and I'm also going to go ahead and just pull in some data that I would want to use maybe for this project. So let me find here, nope, that's not what I want. How about this one? Yeah, I think this is the right stuff. Okay, so I'm going to copy this chord sequence box into this patch. Oops, I don't know if it quite made it. We'll try one more time. There we go. So I've copied that over, and that's the data that I want to work with. And so what I want to be able to do is I want to be able to ask OpenMusic to look through all the pitch material in this chord sequence and count up how many C sharps, how many Cs, how many Ds, D sharps, etc. So I want it to come up with a count for each pitch class, so I can just look at a glance and see kind of what I'm working with. So to begin with, I'm going to pull in a patch that we have already looked at constructing in an earlier video. And this is the chord sequence to pitch class patch. And if you just need a quick little refresher, really it doesn't need to be a patch, but I kind of like having it as its own sort of standalone little module, so I can just reuse it again and again and again. But basically all it does is it divides the MIDI sent pitch information from this outlet by 100. Performs some modular arithmetic, and then flattens the resulting list. So I'm just going to pull that in over here and rig that up. So just so that from the outset we're working with pitch classes rather than with MIDI sent information. And again, if you want to see more about that, you can look at the previous video that mentions that. All right, so the next part we're going to be working with is this pitch circulation counter, and this is the template that I'm going to be working from. But don't worry, we'll be reconstructing that here as we go. And the thing that I want to be able to do as I am going through going through, as I should say, as OpenMusic is going through this chord sequence, is basically tally each pitch class, come up with a tally for each one in a sort of a loop function, so that I can be aware of how many there are. So the first thing that I'm going to do is I'm going to come up with a way of representing these numbers in a way that we can count them easily. And okay, there we go. So I've got that window open, pull this over to the side. So there are lots of ways that you can go about doing this, and there are probably some simpler ways. So a good challenge would be to find an easier way to do this. But I'm just going to go ahead and start by using this substitution function. And I'm going to connect this here. So this is, again, going to be taking the list that I have as an output from this chord sequence to pitch class abstraction. And then I have two values here. So I can ask it to identify a value, and then substitute a new value in as well. So what I want it to substitute in is an asterisk, and what I want it to identify is a 0. And so I'm going to evaluate this so that we can see the result. So let's compare this list with the new evaluation, and sure enough, you'll see zeros have been changed to asterisks, which is convenient. And so now what I can do is go ahead and make a new loop. So I'm going to double click over here and make an OM loop and add one inlet with Control Shift greater than, and go ahead and connect that up. And now I'm going to double click here, and I've got this this nice little loop. Okay, so I'm going to just go ahead and get started. Oh, actually, you know what? I don't need to do that. We're going to move that over, move that down. So, so what we want to do now at this point is have this loop basically, figure out how many asterisks there are in our list. So again, as I'm looking back at the way that I programmed this initially, I think there's probably an easier way to do this. So I'm going to do a little bit of experimenting here as we go. But let's just go ahead and start with a list loop to work through, again, each item in this list sequentially. And then we can just go ahead and do EQ here. And I'm just going to go ahead and double check the documentation on this to make sure that I know exactly what it's doing. So I'm going to type D, or maybe get info. I don't know if this one has official documentation. Yeah, okay. So probably what I'd have to do is go look in the OpenMusic documentation and just double check. I mentioned in an earlier video, there are several different types of these checks in OpenMusic for different types of equality. Yeah, they have some for strings. Okay, and here's a great, this is what I was after. So if two objects are identical and not only have the same value. So I think this is what we want because we're going to be working with this asterisk symbol rather than a number. So we're going to have that plugged in there, and we're going to set that to detect asterisks. And then we're going to do an OM if. So if this is true, then we're going to go ahead and pass a true value, t, to a counter. And like you might imagine, this counter is just going to keep a running tally anytime something is true. Then we can go ahead and connect this down here. Close that. I'm going to go ahead and close that too. And let's quick run it and see what we get. 21. All right, and I'm just going to cross-check that with what I've already done. And yeah, that's the right number there. So again, you might be saying, well, why don't you just ask it to detect zeros if 0 is what you're interested in here? And the reason why is I want this to be a flexible sort of tally so that I can also use it for other pitch classes. So this way I can have this same tally, copy it over numerous times and use it and just change the value here. Maybe an even simpler way, let me give this a try, would be to make another input. So let's do this actually. Let's get rid of that input. I'm gonna just copy that over. Let's delete that actually. And what we could do that would make this even more streamlined would be to add another input and then just attach that there. And I don't know if that input is going to show up. Let's try this instead. Okay, yeah. So let's delete that, add that over. And actually, this should be better because it should allow me to just specify 0. There we go. Oh yeah, that's awesome. That's great. Okay, so this is actually even better than what I had been working with before, because now we can just change, change the value. Oh, that's right. Yeah, and it'll give us a count. Great. Okay. So that'll let us do that, which is really convenient. And then maybe one more thing that I want to do is have a way of making this intelligible to me as the user, kind of on the other end of this whole process. So what I'm going to do is I'm going to use a function called xAppend, which is going to add some items to the result of this and package it all as a list. So what I'm going to do is, actually this would be a great way to do this. So let's go like this, type that in as a 0 and connect this here. And so the result that I'll get in the listener is something like this, where it's going to show me I have 21 instances of pitch class 0. Or if I wanted to, I could disconnect that and make it like even more explicit, so that when I read the data, I know exactly what it is that it's talking about. Cool. Alrighty. So that's something that can be helpful. And I'm actually going to take this one step further. Let's try, I'm going to use a function called number2string. Is this the one that I want? Let's see. String to list, list to string, string to ASCII. Let's try list to string and see. This is from a special library called OMRuben. R list to string. And I don't think, okay, yeah, I think that'll work then. So what this is doing is it's going to take the number in this box and it's going to represent it in OpenMusic rather than as an integer, as a string. So the computer isn't thinking about the number 3, it's thinking about the Unicode character 3, or whatever representation it's using to represent that string. And the cool thing that I can do with this now is use another function called concatenate. And with this concatenate function, what I can do is I'm going to tell it that I want to concatenate some strings. And again, a string is just a certain length of text information rather than like a number. So I've got one string, which is this digit 3 represented as text between the quotes. And so what I can do is type in another string, like instances of pitch class blank, and then connect this here. And what it will do is it'll automatically, not plural, just a string. There we go. So what I can do then is connect that to this xAppend. And so the data that's formatted out will say, 21 instances of pitch class 3. And really what I could do then is even get rid of that slash in the middle. That's kind of unnecessary. So let's take away that inlet, connect it right up. And this is going to say there are 21 instances of pitch class 3. There are 21 instances of pitch class 0, 19 pitch class 1, and 11 as well. Just one more to try. Yeah, awesome, awesome. That's so great. All right, so the last thing that I'm going to do then, this is actually kind of streamlining in some nice ways. So the last thing that I want to do is have this whole kind of function automatically tick through all 12 pitch classes. so that I don't have to keep on entering in numbers and jotting it down. So what I'm going to do is I'm going to take this, this whole group, select that, and copy it. And I'm going to make a new internal patch. And maybe we'll just call this like tally pitch classes. So we'll open this up and paste our information in here. And we're going to need one inlet for our pitch information list that's coming in. And by the way, sometimes when you're working with patches, I don't think I've mentioned this, you can actually rename the inlets so that when you're on the outside of the patch, it'll be a helpful reminder. So you could say, pitch information list as that inlet. So we'll do that, and we'll add one more inlet. And this one we're going to connect here and here, just like we had with that integer box, where where the number 7 is. So that's going to be the pitch class number. And then we need one outlet for our X append down here, so that sends that out. Excellent. So we've got this nice little internal patch finished up. And I'm going to go ahead and connect it here. And now I'm going to use a special function. Well, I'm actually going to use a couple different functions. So the first one that I want to use is an arithmetic sequence. Oh, arithmetic series, pardon me. There we go. And this is a really handy little function, and it's kind of like a counter. It's going to produce a list that counts. So you tell it where you want to start, and you tell it where you want it to end, and then like what the step size is in between each element of the list. So because we're counting pitch classes, we're going to start with a 0, which is great. We're going to go up to 11, and we're going to count by ones. So if I evaluate this arithmetic series, we get a list of pitch classes, which is really handy. So I've got this here, and I could just try and connect it this way and see what happens. But again, it's not going to work because it's only it's looking for this whole list within this list, and that's not what I want. I want it to iterate through individual numbers of this arithmetic series list that I've made. So to do that, I'm going to use honestly one of the best functions in OpenMusic. It's such a powerful way of using the software. It's almost kind of magical. So I'm gonna double click here, and I'm gonna type in MapCar, and this function. It kind of does what it says. I'm not going to get into the car part of it. That's something that relates to the Lisp language, and if you're interested, you can look that up. Car and cdr and all the little functions that Lisp was built with. But what it's going to do is it's going to apply this function to every element of a list that I give it. So it has two inlets, one for function, one for the list. Function, list. And again, it's gonna take this function that I've made and apply it to all the elements of this list. But, and this is the really critical factor that can be tricky to understand at first, or at least it was for me. To make this work, this abstraction that I've made, this little patch, has to be set on what's called Lambda Mode. So to get this set to Lambda Mode, we're going to type B to lock the patch, and then I'm going to click on that X in the top left corner. So now it shows a tiny little 1, and I apologize, I'm sure this is hard to see, but it shows a 1, I click again, and now it shows the Greek symbol lambda. And let me just go over here and just so you know exactly what it is I'm talking about. The Greek symbol lambda. That's what that looks like. So that's what it's showing. And what this represents, this means that this patch, rather than evaluating, is going to pass itself as just a generic function to this MapCar object, which is way cool. It's a really convenient thing again. So let's go ahead and select MapCar now and evaluate. And sure enough, it does exactly what we would hope it to do, which is iterating through these various elements of the list, all the way from 0 through 11. So now if we want to get rid of this, we can, because it's all contained in this tally pitch classes patch. So we can clean that up, move this over here. And then the last thing I'm going to do is I'm going to add one last little object just to be able to read this more clearly rather than checking the listener, which can get a little bit messy. So to do that, I'm going to add a text file object, which is this handy little window. And I'm going to resize it, make it a little bit larger. And then I'm going to click in this area and type M, and then connect the outlet to the second inlet here. And when I evaluate, you'll see we get a lovely little list here, just in kind of plain text, where we can see, again, at a glance, how many instances of each pitch class there are. So this pretty much wraps up this pitch circulation calculator. And along the way, we looked a little bit about formatting lists. As we were getting into this tally function and ways of checking and looking at the formatting of the list. Some fun stuff with strings and concatenation. And a really powerful feature of the language using MapCar. And maybe the last thing I'll say is, this has been really useful as I'm working with pitch material, for example. I don't know why that's not letting me open this up. This is really strange. Okay, we don't need that. Maybe it's on another window. Anyways, usually it lets me open that up. But as I was working through this this harmonic material, it was really helpful for me to just take a look and see, kind of where this material was centered. So, for example, 27 instances of pitch class 4 told me, wow, okay, this is, I guess, mostly even distribution among all 12 chromatic pitches. But D sharp / E flat might stick out just a little bit more than other ones. And by the same token, B with only 19, or I guess actually G with only 17 instances in this harmonic progression is going to be the least heard pitch. So if you're doing anything with maybe post-tonal type harmony, or even if you just want to analyze a passage, if you have a MIDI file of a 12-tone piece or a tonal piece that you want to analyze, this can be a really helpful way of just getting some quick statistics at a glance about how frequently different pitch classes are arising. So thanks again for watching this video. I hope this has been helpful for you. Let me know if you have questions, comments, if you come up with ways of improving on any of this material in this patch, and I look forward to seeing you in the next video.